Hello, everyone. Welcome again to the robotic classes. My name is André Dias from Academia de Robotica in Portugal. And today the topic will be Arduino, LED RGB, PWM signal, and input digital signal. This video was supported by the Erasmus Project Discovery Robotics via STEM. For starting, let's define what will be the topics and the goals that we have for today. Today we're going to explore what is a LED RGB, what is a PWM signal, and also what is an input GPO signal. To validate this, we're going to have some challenges where we're going to combine the microcontroller Arduino with LED RGB and also explore what is a PWM signal and how can we use with the LED RGB. For starting, the list of material that you need to have with you is the microcontroller Arduino, the LED RGB, resistance with the value 330 ohms, and also one resistance of 10 kilo ohms, a breadboard and a bottom, okay? And also don't forget to have the M-block software with you because the code will going to be developed in M-block. For starting, let me introduce you the LED RGB. The LED RGB is a LED where we can control the color that we want to have in the inside of the LED. Normally, the LEDs have fixed colors like red, green, or blue. In this case, with LED RGB, we are able to control the colors like red, green, and blue, and also combine colors to have a new color. For example, if we combine red with green, we're going to have yellow. If we combine blue with red, we can have pink. If we put all the colors together, we can have white. Okay? So today, we're going to explore how to use this component, the LED RGB, and have different colors. To do that, we're going to need to have 3 resistance of 330 ohms, the LED RGB, a breadboard, some wires, and the Arduino. As you can see here, what we have is we have one pin that will be connected to GND, and we have 3 pins that each one of them will have a resistance and connected to the Arduino. As you can see here, the pins, the color of the wire is representing the pin controller for each component. As I said before, inside of the LED RGB, we are able to control the red, the green, and the blue. And here, I'm representing that this pin here is responsible for activating or disabling the red component. This pin is responsible for activating and disabling the green color, and this last one for the blue color. Okay? So for starting, let's assembling the LED RGB, taking in consideration this. Another important information that I don't say before, but is important to say to everyone, is that the negative pin is the pin with the leg bigger than the others, okay? If you see, each one of them has different size, but the most important one is to see that this one, the second, that is called the cathode pin, will be our negative pin that must be connected to GND, as you can see here in the figure. So I'm going to switch the screen to everyone see the assembling procedure. Okay, for starting, let's pick the LED RGB. As you can see here, we have different size of pins, okay? But the most important is to make sure that this pin, the one that has higher leg, is going to be input here as the second pin in the assembly, okay? Then we're going to add the resistance. The first one is representing the red. The second one is the negative that I'm going to connect to the negative here. The third one is the green component. And the last one is the blue. Okay, here I have the three. Now I'm going to put the wires and connect to the pins that we defined. So the red one will be connect to pin number 9. The green one will be connected to pin number 10. And the blue one will be connected to pin number 11. Okay. Here we have the LED RGB assembly. Now, back to the code. Okay, back to the code here. Now, what will be the challenge? The challenge is to perform the switch between the 3 colors that we know that the LED is able to do it. If we want to have the red color, what we need to do? We need to put this pin high and the others too low. This will activate the red component. Next one, if you want to check the green color, we need to put high the pin number 10 and the others too low. And we're going to have in the LED RGB the color green. If you want to have blue, we need to do the same as you saw before. Turn low, put the pin 9 and 10 to low, and pin 11 in state high. Okay, so for testing, we're going to do this sequence. We're going to have a sequence where the Arduino will be in the loop forever, and at each second is going to switch between red, green, and blue. Okay. Switch again to the code to everyone see the code happening. So for starting, we need to have Arduino program as normally, to loop forever. And then we need to have 3 pins, 3 digital pins. Okay. 1 pin will be number 9, number 10, and number 11. First, we need red, so this will become low, low. And with this instruction, we are doing the red color. And then, if you duplicate this and change the value to low and activate this one, we are doing the green component. And then duplicate again by doing low, low, and last one high, we are doing the blue color. Let's check if this is what real happens in Arduino. So connect and then upload the code to Arduino and let's check if this is true. Okay, what is missing? Is missing the power supply that we don't put it in the breadboard. Okay. Now, as you can see, we are doing the colors as we define. Okay, now that we have already completed this task and we have the 3 colors working correctly, let's go to the next challenger, okay? Don't forget that if you have any doubt, you can stop the video and back again and see what are the doubts that we have in the code or in the assembly. Now we're going to explore what is the PWM signal. PWM signal means the letters PWM means pulse width modulation. This is special pins that we have in Arduino that are able not to provide a value of 0 or 5 or zero, low and high, but are pins that are able to create a pulse width modulation signal that have this output, and that output, this means that during one period is able to have some period high and the other low. And the value that we apply in this pin, pulse width modulation, we can have a value between 0 and 255. So if I put in that pin 0, I'm going to have 0 volts. If I apply, for example, 127, we're going to have 2.5 volts that represent 50% of the possible output. So we are going to have half state high and half state low. So we're going to have 2.5 volts as output. If we apply 225, we're going to have the state high, that is 5 volts. And how can I identify what are the pins that are able to work as PWM signal? If you check in your Arduino, you're going to see that some pins have this symbol. This symbol means that the pin is able to work as input and output, and at the same time is able to work as analog output, okay? And the analog output will be the pulse width modulation signal that you can have as outside. So why we are discussing the PWM signal with the LED RGB? And the answer is easy. With the PWM signal, we are able to control the intensity of one color that we can have in the LED RGB. This means that if we have the LED RGB connected, the pin of the LED RGB connected to the pulse width modulation signal, I can change the value of the, for example, the red color between 0 and 225, okay? As you can see here previously, the pulse width modulation signal, it's a signal where we can apply a value between 0 and 225. 0, the LED will be off, 225, the LED will be high and on with all the red component visible. But if we apply, for example, 127, you're going to see that the red component will be lower, and you see that red will be with half intensity that is able to have when we apply 225. Let's check if it is true, okay? To do that, I'm going to switch again because the circuit is already prepared. The pins are correct, so I connect the pin 9, 10, and 11 are the pins that are able to work as pulse width modulation. As you can see here, 9, 10, and 11 are pins of PWM. So the first challenge is to be able to have different values of intensity in the red component. Okay. So now I'm going to switch this code because now I don't want to have the intensity between low and high. I want to have the intensity by using the pulse width modulation signal. So I want to use here the pin number 9. pin number 10 and pin number 11. So, for example, if I want to have the red component with half intensity, I want to have here, for example, 127. Let's see what happens to the LED when we apply this. Okay, the red is turned on with intensity of 127. Let's decrease this value to 50 and see if the intensity decreases. Okay, decrease. So at this moment, the value is smaller than the previous one. For example, if I increase to 225. The intensity is higher than the previous one. This means that with the pulse width modulation, we can mix colors. You have the component red, green, and blue, and you can do the mix of colors. For example, if I mix, for example, one part of red and 225 here in this one. Let's see what is the impact. Okay, we have here a color that is little pink. I don't know if you can see by the webcam, but for example, if I decrease this, we are going to have a different color. Okay. For example, if we want to do yellow, let's see if we are able to do yellow. Okay, more or less yellow. If you want yellow with more red than the green, orange, it becomes orange. And for example, the opposite, if we want this becomes smaller, and this, the green with more intensity. Okay. So as you can see, with this instruction and by using the PWM signal, you're going to be able to do the color that you want between 0 and 225 to each one of the components, red, green, and blue. Okay. Back again to the slides to keep discussing more examples. Now I have a challenge for you. Let's try to develop a code that is going to do the following steps. First, we need to have a variable called value r that must be incremented by 10 at each 0.5 seconds. This means that we're going to increase the component red at each by 10, increase by 10 at each 0.5 seconds. And apply step 2 and apply that value to the red component by using the PWM signal in the red component. Step 3, if that value becomes higher than 225, that is the maximal PWM value that we are able to apply, we want to put again, put the value R to 0. Let's see how to do it. I have here some instructions here, and let's see if you are able to do it. As you can see here, we are using the repeat until, and we are defining that we're going to do this block until the value R is higher than 225. That's the instruction that we say here in the step 3. Repeat until the value R become higher than 225. And what we want to do it while we are inside of repeat until. We want to set the value plus 10 until 225. When we achieve 225, we want to put the value R back to 0. Okay? Let's do it in the code and see if everyone understands what we are developing. So, for starting, let's pick the blocks that we identify, create variable value R, set at beginning the value to 0. Now, repeat until we achieve 255. Okay? As we say in step 1, we want to increase the value by 10. And be blocked here. Applying to the R component the value that we have here. So we're going to be blocked here in this block repeat until, and we're going to increase the value R by 10 at each 0.5 seconds. 0.5 seconds. So we are here in this block, repeat until, and the condition that's going to leave us to outside of this block is when the value R become higher than 225. When this occurs, what we want to do it? We want to clear the value R block. So we want to do this. Okay, so we're going to be repeating. When repeating and applying that value in the PWM signal in the red component, that is number 9, and when we achieve that value, we want to put 0. Okay? Let's upload to Arduino and see if this happens. So the impact will be that the red component is going to increase slowly at 0.5 seconds. It's become more intense until achieve 225. When it achieves 225, it's going to switch again to 0. As you can see, it switched to 0 and starts increasing again. It achieves 225 and goes down again. Okay? Let's go back to the slides. So the code that we see, it's here. You can stop the video, see again, and do it by yourself without seeing the code, and then compare your code with the one that I propose here. Now, let's go to the last point that I want to explore with you. And the last point is to understand how to use the bottom as an input pin. As you can see here, we have here a bottom, and we have one side of the bottom connect to the power, to 5 volts, and the other connect to GNG. While we are, and the pin is connected to pin number 4 here in the Arduino. What happens is the following. When the bottom is not pressed, we have the pin connected directly to GND, to the negative. So in pin number 4, we're going to have the value 0. When I press the button, I connect this point to this point. So the digital pin will change from 0 to 1. That's it. That's the way that we are able to detect when the button is pressed or not. How we do it in M block? As you can see here, we have a block that is called read digital pin, where we can access to that value 0 or 1. So this block, when I call, I'm able to receive the state 0 or 1, 0 when is not pressed and 1 when is pressed. So I have here a new challenge for you. Considering the block that you already done, the hardware that you already have done, let's introduce a button and implement the following. Step 1, detect when the button is pressed. If the button is pressed, increase the value by 10. If the value is higher than 225, put again the value to 0. And apply this value directly to the PWM RGB pins. In the previous example, we were applying only to the red component. Now, we're going to apply this to all the pins, okay? So, for starting, let's do this, assembling the bottom in our circuit. Back to the circuit. I have here one bottom, okay? Let's connect here. You need to have a resistance of 10K. That is going to be connected to the pin of the bottom and also to the GNG pin. The 5 volts pin. And now the positive pin of the bottom is going to be connected to the positive. And as I said before, the pin that is between the bottom and the resistance is going to be connected to pin number 4. Okay? If you have any doubt, please back again to the video and see the circuit. Okay? You can stop the video and check the circuit. So let's try to implement. I have here some ideas how to do it, some blocks that are not connected. And as you can see here, we're going to have something that needs to read the digital pin and check if it's equal to 1. And when is equal to 1, what do we want to do it? We want to set the PWM pin equal to the value, and at the same time, we want to increase our value by 10. Okay? Okay, let's do it here. I'm going to create a new variable that is going to call value. Okay, change here to value. And use this code. And please value here. Value here. As I said, now we want to apply that value to all pins of the PWM. So we're going to see the brightness of the LED white increasing until achieve 225. But to increase, what I need to do? I need to check pin number 4. So I need to read pin number 4. To read pin number 4, we need to check if the value is equal to 1. So read digital pin and check if it's equal to 1. If is equal to 1, what we want to do? If is equal to 1, what we want to do? We want to increase the value by 10. We're going to put here some weight, because when you press the button, we need to make sure that the Arduino only reads one time that you press the button. To do that, we are applying here a wait 0.5 seconds to make sure that we're going to read again if someone is pressed after 0.5 seconds, okay? It's just a debounce protection. And now, what we need to protect, we need to make sure that if the value is higher than 225, we want to set again to 0. Okay, so if the pin is equal to 1, we are increasing the value by 10. If the value is higher than 225, we want to put them as 0. And then, after this, if that check if the button is pressed, we want to apply that value to the LED RGB with the PWM signals. Okay? Let's upload this to the Arduino and check if the LED RGB increase the brightness while we are pressing. I hope everyone is able to see the brightness increasing. And then we achieve 225 and we back again to 10 or to 0. Okay. Back again to the code. Okay. So just to conclude, I hope everyone understand what have been the steps, understand how to use the PWM signal, how to use the LED RGB, and also how to read the input from a button. I hope everyone enjoy this video class, and I hope you see you next time. Bye. Thank you.